Hi, Honors Physics students. Here are some hopefully very helpful hints to get started on the Chapter 6 text assignment. Number 51. When things are thrown horizontally, it means that VV1 equals 0. And that's going to be the case in several of the problems. And recall, this is a very important starting point. If you can't start with that piece of information, the rest of it is not solvable. So you have VH equals 8.0 meters per second. D sub V is 64 meters. That's how far it falls. And remember, writing the knowns and unknowns is very important. Here's a crucial hint. Here's the note. If ever you find a Chapter 6 formula that lacks only one unknown, you should solve for it because it will be very important to solve for that to use it later. So for instance, there is a formula, dV equals VV1T plus 1/2 GT squared. Okay, that's an important formula. Now notice that the VV1 is 0. Well, that means that there's only one unknown in this whole formula. The 64 meters is the vertical distance. The acceleration of gravity can be a positive 9.8. No reason why not, because everything's downward. And then you could solve for the t, and that's very useful. Now, once you solve for the t, you can use it in for other pieces of information. So, for instance, it asks how far from the base of the cliff. Well, then they're asking d sub h equals question mark. And of course, you'll have a d sub h formula. D sub h equals v sub h times t. The rest of it should fall into place very nicely. Number 52, very similar. Again, the car, this time, has a VV1 equals 0. So again, same technique. You can solve for the time it takes to fall. They may ask different questions after that. For instance, after you find the time of fall, okay, then you could use the DH formula, which is VH times T, and solve this time for the beginning horizontal velocity, which was also the beginning total velocity in this problem. Very nice. Let's switch to number 55. Okay, again, another one in a row. You're seeing a pattern here. You are moving horizontally. Now you're trying to solve for how high. How high represents d sub v. And how far from the edge? That represents d sub h. So again, you see the pattern. That problem should be very reasonable. Now we're getting to the crucial problems where something is projected up and comes down. There's symmetry to this parabola. First, you should find the VH and the VV1. The VH is V cosine theta, always, and VV1 is the V sine theta. So once you find those, then you could use, so after you find that, there is an important formula from the notes, and this is one of the most important ones for the up and down, and that is time to the top. Now the time to the top is 0 minus VV1 over negative 9.8. And you could find that time and then use it with the d sub v equals, same formula we're getting used to, VV1t plus 1/2 GT squared. And that would allow you to find the maximum height. Well, if you want to find the range, which they ask in part B, then you could certainly use the dH equals VH times t, and that gives the range downfield. Number 59 is exactly like number 52, so use that as a little hint. Number 61 and 63 are ones dealing with centripetal acceleration. So the centripetal acceleration formula, there are two of them, and in the first one, why not simply use v squared over r, and then it's not that bad. Remember to convert units when you need to. For instance, in part B, you need to find the period. The period, capital T, should be in seconds per revolution. Well, there's a slight problem. They give you 33 1/3 RPM, which means revs per minute. So you'll have to find the reciprocal of 33 1/3 revs, write it as revs per minute, Okay, once you find the reciprocal, then convert to seconds per revolution. Well, after you finish that, then the formula that fits so perfectly is a sub c equals 4 pi squared r over t squared. And that would be quite useful to finish the solution. That should help.